again, I'm going to approach it by cases, okay? And it's not that hard. You start to see the pattern very quickly. Rather than develop it by quadrants, which you saw before, I'm going to do the kind of quick version, okay? So for instance, where x and y are both positive, I'm going to take the positive case for both of these, right? So you have positive x equals positive y. We know exactly what that looks like. That's fine, okay? And just rather than going around in like a clock, right? I'm just going to go straight to the opposite quadrant. Think about what's happening over here and how it's an analog for what's happening up here. X, positive or negative? Negative. Y, positive or negative? Both negative. So I'll take the negative case for both, which means negative x, negative y, which of course is exactly the same as what we just graphed, right? It's still y equals x in this quadrant, okay? Now, what happens when you go to these quadrants? Well, before I do any of the algebra, just think, right? If one's positive and one's negative, right? You'll either have y equals negative x, or you'll have x equals negative y, both of which are exactly the same thing. And that's why you have this guy. And that's it. That is the absolute value of x equals the absolute value of y. Not hard, right? No deal. Okay, so that's simple. Now this guy will take a little bit more time, okay? The approach with all of these is just to think about from the inside out and just develop it slowly, okay? So I'm going to begin by doing my components. You ought to be getting to the point where you can start to see if I give you just a simple absolute value like that, we should be starting to get to the point where you can see what it's doing, right? Where's x plus 1? It's going to be higher. And then it should bounce, right? So here is the absolute value of x plus 1. Excuse me. Now, just as before, see how I've got a negative here, right? So what I'm going to do is I'm going to draw an upside down absolute value graph where everything is negative instead of everything being positive, okay? So think, right, we'll do x minus 2 first, so that's down here, So it would be bouncing over here, right? That's the absolute value of x minus 2. But before I draw it in, I'm going to turn it upside down, okay? So this intercept over here is negative 1, which means that this intercept over here would be 2, right? And I've got the same kind of shape happening. Okay, so we've seen this before, right? Now I want to draw this thing, the subtraction, and then I'll make everything positive, right? So I'm still not there yet. I'm doing my components. I'm going to go from here all the way down to here. And I showed you the logic as to why, right? I'm adding these two graphs together. I'm adding them together. So 0 plus something down here will be something down here. And 0 plus something up here, you get the idea. They're both linear, so the dots joining them will also follow a linear pattern. And then these guys are exactly opposite. So I'm getting this guy over here, and then I've got this guy over here. Right. Finally, I've drawn what's inside the outside absolute value side. And now, to put these in place, I make everything bounce upwards, right? Everything, okay? So up here, this is all happy times, because it's all positive, right? But over here, this is going to reflect upwards, right? So whatever that y-intercept was going to be, it's going to be a y-intercept up here. I'm guessing something like this and across. Okay? Now clearly I'm going to have to find all of these numbers, but that's not that hard, right? Because if I want to find this x-intercept here, all I have to do is put y equals 0 into the whole thing, right? And that's not that hard. And I can do the same thing for x. Who's already got the values for us? Yep, Mitsu. Can I have an x-intercept?
1 over 2.
1 over 2? And up at 1, which is because my scale was pretty close. There you go. Not too bad for hand drawn, okay? So that's it, right? Now, of course, there's one more step which is kind of helpful. All of these 4 branches, they all have their own equation, okay? You can already start to anticipate what this equation is going to be, right? Think about it. It's above the axis. I've got a 1. I've got a 2. What do you think it's going to be? It's going to be 3. Y equals 3 over here. Y equals 3 over here, because it would have been negative 3 down there. What's our combined gradient in here and in here? It's 2, isn't it? Think about the pieces that you've got. What else could it be? If it was a 3, where would it get the 3 from, right? So this is going to be 2x because it's positive, and then I'm going to be minus 1, right? That's what the intercept would have been. Which means that this guy over here is going to be negative 2x because it's decreasing, and it has the opposite y-intercept, plus 1. Anurag.
I get everything except for how you got the half.
This one in here? Okay, all right. I didn't skip over that. I suppose if I want to go into detail, I would step back a bit. How did I get this blue equation in here? How did I get this? Right?
The two green equations added together.
Yeah, good. It's the 2 green equations, but it's in this particular domain. Okay? So to the right over here, I'm going to be taking the positive cases for both, which is why the x's cancel, right? And then over here, I would have taken the negative cases for both, which is why the x's cancel, right? But in between here, I've got 2 different ones, right? Think about this. I'm going to put my green equations in here so you can help me see this. What was this first one that I drew? What were its equations? They came from here, didn't they? So I've got x plus 1 over here. That would make this negative x minus 1. I'm not interested in that though, because I'm in here. Yeah. What would the equation of this part be? It comes from here, doesn't it? This part in here has a positive gradient, right?
X minus.
So this one's going to be x minus 2. Okay, this part would be 2 minus x, but I'm not interested in that part. Okay, its equation is very easy to work out. Okay, so now I have this part and this part. That's what's going to come together, right? So the blue line is the sum of these 2. Okay, so blue. The equation of the blue line here would be y equals 2x. I've got a plus 1 and a negative 2, so that should be minus 1, right? And all I have to do is pop y equals 0 into this to find its x-intercept. Y equals 0, that would be 0 equals 2x minus 1, 2x equals 1, and there's my x-intercept. Okay? So you can see how each step along the way, and like having lots of colors is super useful because you can tease apart all the different steps and not get confused on yourself. Okay. Also, in the same way, if your diagram is too small, everything's just going to, all the equations are just going to crowd on one another, and it's going to be very hard to see. Okay. Any last questions on that one before I do our parabola? Excellent. Okay, this one's nice and easy, isn't it? One color. Let's do our parabola. There you go. Okay, no template required. I'll have some intercepts here, don't I? Right? What are my x-intercepts? What are my roots? Negative 2 and 2. And of course, I'm down here at negative 4 because I'm shifted down. Okay. So if I slap the absolute value signs on the whole thing, what effect does that have? Yeah, good. Yeah, just like everything else has been bouncing, right? This part in here is going to come out like this, like that. Yeah. And of course, since our y-intercept was negative 4 before, I should have 4. Okay. I would just try and make sure that this part here should really be a reflection. This should come up with the same gradient that this was going down. Okay, so it shouldn't be, for instance, something like that. You know, the scale would be off. Just watch out for those kinds of little features, right? And up like that. Okay, now, depending on the way you think about it, it's either got 2 branches or 3 branches, right? This inside part, it's concave down. It's this guy flipped around, isn't it? It's y equals 4 minus x squared. Okay, and then these 2 parts on the outside, they each share the equation with the positive case. Okay, so they have the same equation, so you can kind of think of them as 2 parts of the same branch, but they're separate. So I think of them as 2 branches. Okay.